Just like the other rock types, there are different types of metamorphic rocks. We'll talk about classifying them now. The first way to classify them is to determine are they foliated or non-foliated. Foliation is that alignment of the minerals, the platy minerals. Usually it's going to be a muscovite or a biotite. And the foliation occurs when we have that differential stress. So some stress can be coming at a rock from all sides, and some stress can be in a certain direction. So if it's directed, it's the differential stress. So we're going to classify the foliated metamorphic rocks by their composition. So the composition matters. How big are the grains? How big are the crystals? And what type of foliation it is. The non-foliated metamorphic rocks are going to have been recrystallized and maybe not have that directed pressure. That could be the case. Or it also can be that there's not the right ingredients in that rock to grow platy minerals. So that can also be the case. When it's all said and done, the crystals are going to be equant. So this is a marble here, and all the crystals are equant, so they're not flattened. All right, foliated metamorphic rocks. The first one here is slate. Slate is very fine grained, very low grade. Here's a piece of slate. Yeah, piece of slate. And it is not very shiny. It's got some gleam to it, but it's not very, it's not sparkly. You can't see the crystals that are in there. And it's a metamorphosed clay, and it is, clay like a metamorphosed shale or a mudstone. One of the things that makes slate really useful is those flat surfaces of foliation where it breaks. So you can use slate for roofing tiles or pool tables, or slate like a chalkboard. So slate is very useful. The next one is phyllite. Phyllite is going to be a little bit shinier, and it will have like a crenulated kind of wrinkly pattern on it, and it's still fine grained. It's hard to like pick out individual crystals. This also would be like a metamorphosed shale or a mudstone, and this shininess is called phyllitic. A metaconglomerate would be a conglomerate that has been metamorphosed. The image there is a really squished one. This one's metamorphosed. It's not very squished, but it is a metaconglomerate, and it is where you take a conglomerate, a sedimentary rock, and you metamorphose. We find these around Boone, all around Grandfather Mountain and in the Grandfather Mountain Formation. A schist is a rock that we can see the crystals. So this would be fine to very coarse grain with really large micas. This one has really big muscovites in it, but the mineralogy can be different. So we can have a schist that is full of biotite crystals, so that would be a biotite schist. There are also schists that have big crystals in it, so these are starlite crystals within that schistose matrix. So that would be a term, porphyroblastic schist, where it has big crystals in it. A gneiss is a banded rock, and it has light and dark bands define that foliation. The light bands would be the felsic minerals like the quartz and the feldspars, and the dark bands would be those more mafic minerals like the biotites and the amphiboles. Okay, those are the foliated rocks. The foliation here is explaining the growth of that. You start with a protolith that has all the different kinds, mafic and felsic, as you change it over time, you're going to dissolve some of those felsic minerals and some of the mafic minerals, and the ions are going to migrate and segregate into these. They're going to find the like felsics and the like mafics and segregate into those light and dark bands. If that gneiss were to be heated just a little bit too much, some of the rock will melt. Usually it's going to be the light colored minerals. Remember Bowen's reaction series, the light minerals are going to melt at a lower temperature than the mafic minerals. So the light minerals will start to flow and migrate throughout the rock.